Okay, let's get started. Yay, we're back. Everybody happy? Well, maybe, maybe not. Okay, we're doing the Fisher-Gray model. And so far, all we've really done is infrastructure. But we talked about how we're going to write normal values in terms of capital letters. The log of those values, we're going to use small letters, and we're going to use small letters all the way through. We're going to keep track of the time that things are happening, because this is a model that's going to be happening over time, and time is going to be very important to us. And then we had a production function, and our first big assumption was that firms are going to maximize profit, and they're going to be perfectly competitive in the labor market. So they're going to hire workers up to the point where the real wage is equal to the marginal product of labor. Okay. So that gave us this, and that's just coming from yt is equal to nt1 minus alpha, the production function. And firms are perfectly competitive. And I actually should just say we have a perfectly competitive labor market, right? Because firms and workers are both small. They both have perfect information about wages. All the jobs are identical. And so we end up, you pay the marginal product of labor. Now, none of these things are realistic, of course, right? We don't all know the wages of all the jobs on offer. All the jobs are not identical. Some firms are large compared to the market. Some workers are actually large compared to the market because they have specialized skills, and there's not so many people that have those skills, right? And so all of these assumptions are not literally true in real life, but that's how we're starting our model, to say, how many people do we hire as a function of the real wage? Okay? We've done log, so it becomes linear. Instead of W over P, it's a little w minus little p, but it's number of workers hired as a function of this real wage. We could, of course, solve it for n and get in terms of the real wage. Okay. So now we want to take this and use it we're going to try to reduce all this model into something usable. And our first step here is going to be, we're not going to be so concerned with n. We can track n if we want, but we're really going to be concerned about GDP, about y. So I can take this function, and I can take the log of it. So that's the natural log of capital YT is equal to the natural log of nt1 minus alpha, just taking the natural log of the production function. And that gives me little yt is equal to 1 minus alpha times little nt. Okay? And that just says how production is a function of the number of workers, because all we have is workers in the production function. So if we have more workers, we get more output. And so this is how it works, right? And so I can, if I want, and I do, I want very badly, is to write this thing up here, that number 1, I want to write it in terms of y instead of in terms of m. Okay? So I'm just going to combine these two equations. I've got two equations. They don't feel so separate because they both came from the production function, but one of them, the lower one, is just the production function rewritten in terms of logs. We haven't done anything with it. We've just written it in a different way. And the other one, the top one, has a lot of assumptions in it. Right? That has assumptions about this perfectly competitive labor market, each firm maximizing profit, hiring workers up to the point where their real wage is equal to the marginal product of labor. Okay? So lots of assumptions in one. This other one is just a production function. Okay? So the top one tells us how many workers firms hire if the wage is known. I pretend the wage is out there. And the other one says how that translates into output. So I can rewrite this one as nt is equal to 1 over 1 minus alpha times yt, right? Just dividing both sides by 1 minus alpha. And then I see the n all the way up in number 1, and I can plug that n in, and I can write that in terms of y, combining those two equations. Okay? So this is going to be our standard operating procedure. We're going to make some assumptions. Each assumption is going to give us an equation. That's part of our story. And then once we have our equations, we can combine them in any way that we like to get at what we want. Because once we have them in our story in equation form, then any legal math thing we do with it is forcing us to think logically about it. Okay? And that's the beauty of the math. So I'm just going to plug this in. And I am going to get something I'm going to call equation 2, if I can, which is going to be, it's not equation 2. It's going to be close. It's going to be close. It's going to be Wt minus Pt is equal to ln 1 minus alpha plus alpha times nt, but I'm going to write nt as what? I'm going to write it as 1 over 1 minus alpha yt. Right? That's just rewriting equation 1. I haven't done anything to it other than combine it with this other equation. And now I can solve for y. Right, so I do that by putting all this other stuff on one side. So I'm going to have alpha over 1 minus alpha times yt is equal to Wt minus Pt do I have? Nope. This is a minus. No wonder things weren't looking the same. Okay, going on to another page, this is minus. We can see that if we go back. This is a minus here, minus. Following that minus down, things weren't making sense, and that makes sense, right? We should keep in mind that there's a story here, and the higher the real wage, the fewer people they're going to hire. If they're hiring more people, it means it must be that the wage is lower. So there's a, the wage higher, it goes in the opposite direction as the number of workers, right? So that makes sense. It has to be a minus. It can't be a plus. Okay, so rewrite this now. This is ln 1 minus alpha minus Wt minus Pt. The higher the real wage, the less output we get, right? That's the minus here. And solving for yt, and this is going to be equation 2. It's going to be 1 minus alpha over alpha ln 1 minus alpha minus alpha over 1 minus alpha Wt minus the minus clear. Okay. And that's going to be an important equation for us. Okay. The higher the real wage, the lower output. Okay. Anyone shocked by that? Yeah, hopefully not. Hopefully, like the exact story, the exact equation, of course, is all new to you, but the basic idea that if the real wage is high, fewer people are going to be hired, and therefore output is going to be lower, hopefully is clear. Right? It is the particular assumptions get us that, but that's a fairly general result as these things go. Okay. So remember, what we're trying to do is we're trying to get sort of a extended version of this Phillips curve story. Right? So now we have a story about the firms hiring workers based on the real wage. Right? And that's kind of our Phillips curve, right? The higher the real wage, the less firms want to hire. However, what we don't have is expected prices yet. This is just prices are, right? Remember in that story, people set their wages, and then firms hired as many people as they wanted at that wage. So that's what we have so far. If the wage came from somewhere, we don't know where, but if the wage came from somewhere, it was fixed in short-term contracts, that would give us the amount that people would hire, and this would give us the output. Right? So we have output here. We could have done it in employment, but we want to do it in output, because it's the standard way to think about these things. Right? Okay. With me here? Yeah.
Why is it alpha divided by 1 minus alpha, and that's 1 minus alpha divided by alpha?
Because I screwed up. Thank you so much. Yeah. So true, so true. Over alpha, because what we did is we multiplied by 1 minus alpha, we divided by alpha. Absolutely. Thank you. Thank you so much. Like, once you go like 10, a whole page with wrong algebra, it's hard to back it out. So it's really helpful to catch it early. All right. And as you can see, algebra errors, they're a problem. When you're doing your homework, I recommend, we don't have yet, but when we get to homework on this stuff, I recommend doing it with a friend so that you can catch each other's algebra errors and help each other along. Because, never do algebra in public, but never do it alone either. Like, you need a fine line. Okay. So now we need the other part of the model, right? And the other part of the model was the wage setting. It was this idea that people were in short-term contracts. They looked at expected inflation, and they decided their wage accordingly, and that wage was going to last for a while, right? And so in that story, we're really wondering, where does this wage come from, right? And in that story, people were forward-looking when they were setting their wages. They didn't have all the information they needed when they were setting their wages, but they had to set their wages anyway, and they had to have those short-term contracts. So we want something similar to that to be telling the same story in math that we were telling in graphs before. So here's how we're going to do it. We're going to say there's, let's get it in black because this is the assumptions, not the explanations. Capital WT, again, I'm putting little serifs on it so it's clear that that's not T. I'm going to call this bar is equal to capital W T over PT given T minus 1. So now we have new jargon. Okay? I've written this thing, I've written two things that you don't know. W you've seen before, that's the wage. And capital W is some kind of constant that I haven't explained to you. And we've got this thing, PT, vertical bar, T minus 1. What does that mean? Well, we're going to use this notation to say PT given T minus 1 is our expectation. Actually, it's going to be, people's expectation of PT given So the idea here is that I'm at time t minus 1. So I'm 1 year before where I'm going to be working, right? I'm at a time before when I'm going to be working, and we have to come together on a contract. And I'm going to be stuck with that contract for a while. And this while is going to be one period, whatever the length of period is, say a year. Okay? I'm going to be stuck with this contract for one period. So at the beginning of the period, t minus 1, I'm going to set my wage along with my employer. We're going to negotiate this thing out. And then I'm going to be stuck with that. So the idea here is that employers and workers have some kind of, let me put it in quotes, target real wage. Not real wage, that's Gandalf. They have some target real wage. That's not really a target, right? Because workers want to work for 100 million euros per hour, and employers want workers to pay them to work, and they have to come together somewhere in the middle and come up with a wage. And the idea here is that just like in our other story, we don't really know where this real wage comes from, something about the bargaining power, something about the elasticity of labor supply versus elasticity of labor demand, and all that usual stuff. But if we knew the prices for sure, right, if it was just PT, then we just say there's a supply of labor, there's a demand for labor, and it comes together at some point PT, right? We would just sort of draw it. Labor demand, labor supply, that would give us the N, and that would give us the real wage, which we're calling W bar. Okay, so if we knew everything with certainty, which we don't, but if we did, that would be our W bar, something coming out of the labor market. Now, we're not going to have anything useful to say in this version of the model about what W bar is, but we're going to take it as constant in the same way that we did when we were telling the augmented Phillips curve model. We're just going to say there's some labor market doing its thing. If everything was certain and everything was known, would come up with some real wage. Okay? Workers wanting everything, firms wanting to give them nothing. Somewhere in the middle they meet. Okay, lots to explain there, but we're not going to do it here. And it comes up with some real wage. The twist here, and it's the same twist we had before, is that we don't know what the prices are going to be at the time. Right? So we can set a nominal wage, but we can't really set a real wage. Right? One could write this equation. It's not going to be useful for us to write it this way, but we could write it as capital WT is equal to W bar times PT given T minus 1, right? Saying that's where the nominal wage comes from. Yeah?
Why is labor supply going down and labor demand going up?
Because I'm bad at this. Yeah, I should be an economist or something. Yes, that's a very good point. Yeah. Fine. Yes. Yes. Makes much more sense now. Yes. Okay. So that's the idea. We're not modeling this, but it's the same story we had before. We're putting that story into an equation form, and this is what the equation form looks like. Now, we don't have inflation here. We have the price level. That's going to happen next time, but that can be converted into inflation given where you started, right? Okay. So there we are. And the first thing we want to do naturally is take logs of this, right? So we've got ln W bar is equal to ln capital WT over, this is capital, very important. That's capital P. Right? And that's going to give us the brain does not want to think and talk at the same time, equals little WT minus little p t given T minus 1. Okay. And we're going to call this equation 3. This is just that same assumption, but written in terms of logs instead of in terms of capital letters, because we're going to write everything in terms of logs so we can use it in a nice linear way. Okay. Okay, so we've got this, and we've got, what do we got? Oh, I know what I want to do. Okay, so what I'm going to do is I'm going to subtract PT from both sides. Okay, I can do that. What does it get me? You can subtract 20 from both sides. You can subtract 100 from both sides. But I'm going to subtract PT from both sides. And so I get W bar minus PT equals Wt minus Pt given t minus 1 minus Pt. I can do that. Why do I want to? Well, because I'm really interested in what is the real wage going to be, because my other equation had the real wage floating around in it. So I want to get things in terms of the real wage, and the real wage is Wt minus Pt. And so I'm going to write this as W bar, taking the Pt given t minus 1 over here, so I get Pt minus Pt given t minus 1 on the left-hand side, and that equals Wt minus Pt. And this I am going to call equation 4. And this is actually of some interest here, right? Because, not so much because of what it says. It doesn't say anything more than what we had before, but because now I've written our real wage on the right-hand side, little w minus Pt, in terms of price prediction errors. And these price prediction errors are going to be the core of this model, right? It comes in our augmented Phillips curve model. Changes in unemployment came because we misguessed unemployment, right? We misguessed inflation. What a day. We misguessed inflation. Like, we had an expectation of inflation, but if inflation was different from our expectations, things happened to unemployment. Here we're going to have something different, and we see the actual real wage is based on whether we predict the price correctly. Right? So these price prediction errors. Pt given t minus 1 is what we guessed the price would be, and Pt is what it actually turned out to be. Okay? And this is just saying that if the price is higher than what we guessed, then the real wage is low. That's the negative here, right? Which makes sense. We set our wage based on the price we expected, but actual prices were higher, so we got a certain nominal wage, but prices were higher, we can buy less stuff with it. Okay? So there's nothing like novel or particularly shocking about this, but I'm sort of emphasizing it a little bit because we have a story. You've seen the story, you've seen the graphs. We're telling the same story in math, and I want to emphasize the sameness of this story. That if we guess the price wrong, that's going to affect our real wage. If we guess it too low, our real wage will be too high, and if we guess it too high, our real wage will be too low. Okay? Right? Because another way to write this same equation is, well, yeah, not helpful. Let me not switch it over. Okay, so we've got 4. And now I'm going to take this, I'm going to plug it into 2. Let me remind you what 2 was. The downside of this. 2 was yt equals 1 minus alpha over alpha, ln 1 minus alpha, minus 1 minus alpha over alpha, Wt minus Pt, right? That's 2 itself. It says output depends on the real wage. And now we have a thing that says real wage depends on price prediction errors. This W bar, but that's just the constant, and then price prediction errors. So now we're going to be able to write output in terms of price prediction errors by substituting in W minus Pt into 2. Okay. So I'm going to take this bit here, and I'm going to plug it in for that bit there. Okay. So I get let me do it on the next page, and I'll do it on this page. Yt equals 1 minus alpha over alpha, ln 1 minus alpha. Those are all constants, so it's just a constant term out there. minus 1 minus alpha over alpha. And we're going to plug in all of this, so let me put it in brackets here. W bar minus PT minus PT given T minus 1. And you'll notice everything's in terms of small letters now. Like everything we're going to do from here on, almost here on out, for a while is all going to be in terms of small letters. We're going to have one more assumption in large letters, which we're going to switch, but basically we're in terms of small letters now, in terms of logs. Okay. So I can simplify this thing, and what I really want to do is I've got constant term here, right, because alpha is just a parameter of the production function. It's a fraction. And ln 1 minus alpha is obviously a parameter as well. And I've also got a constant term here. All right, so I want to combine all those constant terms. So I got one big block of constant terms, and then I got other things that I got to worry about, these price prediction errors. So that gets me 1 minus alpha over alpha times ln 1 minus alpha minus W bar. That's all the constant terms, plus minus alpha over alpha, PT minus PT T minus. So we go back. Notice here we've got a minus, but we've got a minus inside as well, which is why it turns out plus there, right? Does this make sense? Well, there's a constant, y equals a constant. That's like not shocking. How does y depend on these price prediction errors? If our price is higher than what's predicted, that means our real wage is low, which means output is high. Right? So hopefully that makes sense. But you should, whenever you get a new equation, you should check, does this make sense? What's the story behind this? Right? Now we've combined a few equations, so the little story is a little convoluted, right? It's price high. That means we set our wage based on PT given T minus 1. Price was higher than we expected, and therefore our real wage is low. They hire lots of workers, and output is high. Okay. We could, if we wanted to, solve for NT as well by plugging that same equation into the NT equation, but we're not going to use that, so I don't bother, but we could do that as well. Right? Because if we go back, let me just point it out, way back, we have this. NT is related to W minus PT, the same way that Y was related to W minus PT. So I could solve this for NT, plug in that W minus PT equation as price prediction errors, and I'd get an equation for number of workers as well. Okay. Now I want to define Y bar equals 1 minus alpha over alpha times ln 1 minus alpha minus W bar. And theta, Greek letter, equal to 1 minus alpha over alpha. And I'm doing this just because this is a whole manky mess to carry around, right? We're going to have all this stuff floating around. Why not just give them one letter? We can carry the one letter around. And so I rewrite this. I get yt is equal to y bar plus theta pt minus pt given t minus 1 information. And this I'm going to call equation 6. And this is going to be one of our two key equations in this model. Okay. Now, why did I call it y bar? This is going to be potential output. Right? This is going to be the normal level of output. If we made no price prediction errors, if we guessed price correctly, and at the moment there's no reason why we wouldn't. If we did guess price correctly, then that term, the PT given t minus 1, that whole term, this whole term would be 0. Which means yt equals y bar. So yt equals y bar is, if we have no price prediction errors, that's the level of output we get. Now it's important to note that y bar might be negative. We didn't say anything about what w bar is, so it might be negative, might be positive. Also 1 minus alpha over alpha, we don't know whether, so that's a positive thing, but ln 1 minus alpha, we don't know whether that's positive or not. Actually, we know it's negative. We actually do know it's negative, don't we? It's a fraction, yeah, it's negative, right? Because as you'll recall, ln looks like this, where this is 1, and this is ln of x, right? So we're somewhere down here. Okay. So our little x, our little y bar, is negative. Okay. So should we be concerned about that? We shouldn't, right? Because we have yt is equal to y bar, but that doesn't mean that y itself, right? Because that means capital Y, t, is equal to e to the little y bar, which is greater than 0. Okay. So just because the little y is less than 0 doesn't mean we should freak out, because remember, the little y is the log, and the log can be negative even when the thing itself is positive. Even when x is positive, little x will be negative. And so we get little y is negative, little y bar is negative, but it's not a problem. It just says that it's less than 1, okay, which is fine, right? We didn't determine units of this thing. Is it in trillions of euros, hundreds of trillions of euros? We don't know. So it's less than 1. Okay, so we've got equation 6. And that's going to be our key equation. And that's going to be sort of our goods market equilibrium. That's how we think the goods market behaves. Okay? Everything we've had so far is about production functions and the labor market. So those are two things making real stuff, right? Also services, that's not real stuff, but they're making goods and services, producing output. So that's how output is produced. It comes down to output is determined by price prediction errors. Okay. The same way in the augmented Phillips curve, unemployment was determined by inflation prediction errors. Or in the aggregate supply, aggregate demand model, in short-run aggregate supply, output was determined by inflation prediction errors. Here we've got price prediction errors, very similar idea. And yeah, so there we go. Okay, now I've been throwing in these price prediction errors. Well, we derived them a bit from our assumptions, but we have no reason in this model why anyone would ever make an error. And so in order to really make this useful, to really talk about price prediction errors, we need a reason why someone might make a mistake. Right? So we need to put that in. And we're going to put that in by putting in the financial markets. And this in particular, we're going to be concerned about what can monetary policy do to stabilize output in a recession. Right? So that's where we want to go with this. So I want to put in a sort of financial markets where the money supply, we can see the money supply in action. And so the way I'm going to do this So what I'm trying to get out of adding this financial system is, one, I'm trying to add randomness to the model, so there's a reason why people might make price prediction errors. And two, I'm trying to get something where I have my policy choice in there. And we have prices, so it's very natural to be thinking in terms of the money supply, right? We know if you print money indefinitely, eventually prices are going to go up. And so we would like to see where prices come from in this model, because it's all about price prediction errors, so clearly predicting prices is going to be a thing. We need prices to come from somewhere. Right? So the other thing we're getting is, where do prices come from? And the way we're going to do this is we're going to use the quantity theory of money. So this is capital MT times VT is equal to capital PT times YT. Okay, this is the money supply. This is velocity. Money, this is price level. You can think the consumer price index, for instance, and this is things purchased. Number of things purchased. So on the right-hand side, we have 100 things were purchased. On average, they were 50 euros each. 5,000 euros worth of stuff was purchased. On the left-hand side, we have the number of euros in the economy times the number of times in the year that each euro got spent. So the total amount of spending has to equal the total amount of purchases. And the total amount of spending, if there's, say, 1,000 euros in the economy, and we have 5,000 in total spending, it's got to be that each euro went around 5 times, got spent 5 times. Right? So that's the velocity of money. And this is an accounting identity. This has to be true. But we're going to add some assumptions to it that turn it into more of a theory, but at the moment, it's just an identity. Okay. Now, what I'm going to do is I'm going to divide both sides by y bar. Okay. I can do that. I can divide both sides by anything I want. So I get capital MT, capital VT over capital Y bar is equal to capital PT YT over capital Y bar. Why am I doing this? I can do it. I can divide by anything I want. I can divide by a variable. I can divide by anything that's not 0, right? And I'm fine here. Well, the reason I'm doing it is because if we go back a page, well, 2 pages, we got this thing. And we can write this thing in terms of YT minus Y bar is equal to theta PT minus PT given T minus 1, right? That's just put it on the other side. And so we have this output in relation to the the potential output, right? And so I want to write my other equation in a similar way, so I see output in relation to potential output. And doing this is going to give me that, because here this bit here, capital YT minus over y bar, when I take the logs of that, that's going to be YT minus y bar, little yt minus little y bar. So just to get it in the same thing. Now this bit's not so useful to me. The right-hand side is why I did it. The left-hand side is just a pain. And so I am going to define VT tilde equal to VT over capital Y bar. This is capital VT. And it is just a definition so that I can carry around V tilde instead of VT, and I get what I'm looking for. And so rewriting this, I get, woohoo. Capital MT times VT tilde is equal to PT YT over Y bar T. Okay. Now I can take logs of this. We get ln of the left-hand side, T VT tilde equals ln of PT YT over Y, there's no T on this, Y bar. And just to slow it down, just to because people aren't comfortable with logs yet, let me do it in steps. This is going to be ln of capital MT plus ln of capital VT tilde is equal to ln capital PT plus ln capital YT minus ln of Y bar. Just because I don't want to carry this silly tilde around anymore, I'm going to define little VT equal to the log of VT tilde, just the definition. So this whole thing becomes little mt minus, plus little vt is equal to pt plus yt minus y bar, all in little things. Okay, and we're going to really worry about the real money supply. So I'm going to switch this around to, how are we doing? Yeah, we're doing okay. Going to subtract PT from both sides, subtract VT from both sides, and I get little mt minus PT is equal to yt minus y bar minus VT. And we're going to call this equation 7, which is going to be crucial for us, and this is the money market. And we have our other one, which is yt minus y bar equals theta pt minus pt given t minus 1. This is equation 6. This is the goods market. And these are going to be the two equations that we work with in this model. Okay, so output depends on price prediction errors. Prices are kind of determined in this money market, right? In terms of the money supply, how much output is. But clearly, they're both jointly determined, right? On the lower equation, we got output, how much output is different from potential output, and that factors into the money market as well, right? They happen together. If there's a lot of output in the economy, people want to buy a lot of stuff. That's going to drive prices up. Right? You can. Now, if money is high, that's going to affect prices as well. So we need to determine those two together, and it seems fine until you start thinking about it. You think, what do we need to solve for? Well, we have MT that we don't know. We've got PT that we don't know. We've got YT that we don't know. We've got VT that we don't know. And we got PT given T minus 1 that we don't know. So we got 1, 2, 3, 4, 5 variables, and we've got 2 equations. Okay? So just right off the bat, you can see we do not have enough information to solve this. And this is one of the things that math gets you. Like in terms of why do we do math, it tells you whether you've specified your model enough. Right? If we threw this all together and we start making claims about it, well, we can make claims, but we know from high school, right, if you have 2 equations and 5 unknowns, there's going to be loads of answers to that. So if I didn't specify any more, I could come up with things where these equations were all true together, and I would say, I've solved the model. Except there's going to be many, many solutions, because I got so many variables to play with. And so there's not really enough information in this model to determine all of this stuff all at once. So we need, if we want to know this stuff, we need to put more into the model. And the math is telling us that, right? We need the same number of equations as we have unknowns, otherwise we can't solve it. Either we have no solution if we have too many equations and not enough unknowns, or we have many solutions if we have more unknowns than we have equations. In either way, we're not real happy with our model. It's not giving us useful predictions. We're not really explaining anything. But particularly when you have more unknowns than you have equations, it's very easy to think, if you're not being careful, that I've solved everything. Everything is great. But there's loads of solutions, and you might just have picked one that seemed nice to you at the time, and in fact, there's others that are more relevant. Right? And this is the problem that we had in economics before math became a thing. People would come up with lots of nice stories, but somewhere in their head they weren't specifying all the assumptions, because when you're just holding them in your head as stories, it's really hard to know exactly what assumptions you're putting in there. Right? Some of them you know, but others are sort of implicit and you didn't even think about them. And you get answers, but it's not clear those assumptions are right. It's not clear those assumptions are consistent with the other assumptions that you made. Math is forcing us to say, hold it. You have not done enough with this model. This model is not well specified. We've got more equations than we've got more unknowns than we've got equations. We cannot solve this. Okay, I'll let you go. Oh, one thing to say. I get kind of rushed at the end packing up because people are coming in. If you have something immediate, you can come ask me. But otherwise, I'll pack up my stuff and then I'll go outside here on this floor and I'll hang out. Right? And so that we can talk to each other in a calm way rather than a rush thing.